Okay, I'm going to review a little bit over what we've done, what we did earlier, and that is absolute value. Not one of those super duper whiz bang important things, but you are going to see this from time to time. The absolute value, and that's notated by these two vertical lines on either side of the number, is always, I know always is a long time, but it's always a positive number. Because what does this mean? It means, excuse me, it means how far is it on the number line from zero? And distance, how far something is always a positive number. So if you have the absolute value of 5 is 5, the absolute value of -5 is also 5. Now, if we have minus the absolute value of -17, now what is this saying? This is saying subtract the absolute value of -17. You can you can treat the absolute value symbol as parentheses. So you remember from PEMDAS, order of operation, you do this first. So it's subtract 17. Okay. Now, what if we have this if you're so smart? If x equals, I'm sorry, the absolute value of x equals 7, what could x be? You know, I've been doing this for probably 20 years, and I think I've only had one person ever get this correct. X could equal 7, and x could equal -7, because the absolute value of 7 is 7, and the absolute value of -7 is also 7. Now, what if we have this? The absolute value of any number equals -15. Now, the answer to this is undefined. And I'm going to do this to you on quizzes and tests and whatnot, not because it's important, just because. Because remember, the absolute value is always a positive number. So if the absolute value of x is -15, this cannot be. It's undefined. Okay? Okay. Now, the other day, we talked about complementary and supplementary. MENTA. This is not spelled wrong. This is spelled correctly. COMPLE. If it was COMPLI, it would be, oh, Johnny, you're such a pretty boy. No. Complementary is two angles, not angels, angles, that equal 90 degrees. Supplementary, LEMENTARY. Supplementary angles are two angles that add up to 180 degrees. Okay? Okay. Now, complementary, that is a 90-degree angle like that. Supplementary, that's a straight line. And two angles here, here. Okay. Now, what if you have this? If you have 90-degree angle. Now, I'm not going to do this to you, but you might want to be aware if the little square is not there, it's not necessarily a 90-degree angle, even though it might look like it. But like I said, I'm not going to do this to you, but somebody will along the line. If this one is, come on, stupid thing. If this one's 50 degrees, what's this one? And we have that angle, degrees, plus 50 degrees. We know that these two will add up to, excuse me, 90 degrees. Now we have a real simple algebra problem. Subtract 50 from each side. So x is 40 degrees. Now, the acid test here is 40 and 50. 40 plus 50 is 90 degrees, so we are correct. And if you have basically the same problem, and this one's 20 degrees, this one's x degrees. And again, this angle plus this angle will add up to, they're complementary, so they will add up to 90 degrees. So x plus 20 equals 90. Again, simple algebra. Subtract 20 from each side. X equals 70 degrees. Now, is it correct? 70 and 20 is 90, so we are correct. Okay. Basically the same thing. Am I going too fast? Please tell me if I'm going too fast. This is where you want to stop and get you a drink of your Diet Coke. Oh, that's good. If we have a straight line, this is also called a straight angle, even though it doesn't really look like an angle. And you have two angles will add up to 180 degrees. This one is supplementary. So if this is 56 degrees, and this is, we don't know degrees, we have x plus 56 equals 180. 180 degrees in a straight line. So again, we have a real simple algebra problem. We subtract 56 from each side. So x is, what is that, 124? So I think that's right. If you're not sure, plug it in your calculator. Okay, 124 and 56 is 180, so we are correct. And same stupid problem. If this one's 75, not 25, and this one is, we don't know. This angle plus this angle are, they're supplementary, so we can set up the problem. Come on, boy. X plus 75 equals 180. And you subtract 75 from each side. So x equals, what is that, 105 degrees, something like that. And 105 and 75 is 180, so we're probably correct. Okay. And we're going to kind of shift gears a little bit here. Now, what if we have a straight line here? 180 degrees, right? And we have another one here. Straight line, also 180 degrees. And if this one is 4x plus 19, and this one is 6x minus 5. Now, these are what are called vertical angles. V-E-R-T-I-C. Vertical angles. We like to think of vertical as up and down, right? Now, whoever came up with the definition of these two things is stupid, but that's the way it is. Vertical angles are equal. Vertical angles are equal. This one equals this one, and this one will equal this one. Okay, and we also know that this angle plus this angle will equal 180. Am I right or am I right? I'm right. I'm always, well, sometimes. But we know that vertical angles are equal. Okay, so we can set up a nice, pretty algebra problem. What could be more fun? 4x plus 19 equals, okay, again, vertical angles are equal, 6x minus 5. Right? Right. Now remember, the first thing we want to do in a problem like this is move the variables first. That way you don't end up with some godless negative number. It really doesn't make any difference. You can move the 6x over here, but let's do it like this so we don't get confused. Right? 4x minus 4x is 0. Bring down the 19. So 2x minus 5 equals 19. And again, a real simple algebra problem. We add 5 to each side. What is it, 24? I think so. Equals 2x. Right? Right. Divide everything by 2. X equals 12. Is this our answer? No. We want to know what the measure of each angle is. So we have 4x plus 19. We have 6x minus 5. Now we're going to put 12 in for x. So 4 times 12. Am I going too fast? Does this make sense? Plus 19. Same thing over here. 6 times 12 minus 5. 4 times 12 is 48. This is PEMDAS. We do multiplication first. 48 plus 19. Let's see, 48 plus 19. Come on, boy, think. Is 67, I think. My brain's gone numb. 4 times 12 plus 19 is 67. Okay, so this side is 67 degrees. Now we know that vertical angles are equal, so this one should be 67 also. Let's make sure. 6 times 12 is 72, minus 5 is 67 degrees. Right? Right. Now, what are these two angles? These two angles are vertical angles also, and they will be equal. But this angle plus this angle, everybody with me here? This angle plus this angle, let me rewrite this. Getting really busy there. 67 degrees, 67 degrees. Okay, so this one we know is x. This one is also X or A or B or whatever. So now we do 180 because we know that this angle plus this angle is 180 degrees minus 67 is 113. Same thing here. These are vertical angles, so they will be equal. Now the acid test here is add these together. 67 and 113 is 180. 67 and 113, 180. Now look at that problem. Y'all proud of yourselves? You should be. That's some misery there, isn't it? But it's real simple. Very simple. Mm-hmm. You're going to see that from time to time. You will see vertical angles. Again, not a whole lot, but you will see it from time to time. Now take a drink of your Diet Coke. Oh, that's good. They get this if you're so smart. 4x degrees and 3x minus 30. Degrees. Now, what do we know about these two angles? They are supplementary. They're going to add up to 180 degrees, right? So we know that 3x minus 30 plus this one plus this one will add up to 180 degrees. Now, when you get to this, you think, holy crap, I can't do this. This is way too complicated. No, it's not. What can you do? Ask yourself, what can you do? Well, you can combine like terms, 3x and 4x, and negative 30, all that up to 180. So 3x and 4x is 7x minus 30 equals 180. Am I going too fast? Please tell me if I'm going too fast. You know, you might need another drink of your Diet Coke. Miss Bill, I don't believe that. I think you're out smoking in the backyard. And, now what? Again, now we have a real simple algebra problem. I hate to tell you I told you so, but I told you so when we did this, was it last week, I guess, how important solving equations is. It comes into play in maybe not every problem, but an awful lot of them. So now we're going to add 30 to each side. 7x equals 210. Is that right? 180 and 30? I think that's right. Divide by 7, divide by 7. So x is 30. Now we want to, this is not the answer. Now we want to know what is the measure of each angle. So 4 times 30, wherever there's an x, we're going to plug in 30 and do the arithmetic. 4 times 30 is 120 degrees. Well, whoever made this problem up got the look of it wrong. 3 times 30 is 90. 90 minus 30 is 60 degrees. Now that one, this should have been over here and that should have been over there. Because that looks more like 120 degrees now. But again, now the acid test here is add these two together. 60 and 120 is 180 degrees. So we are correct. Degrees. Right. Everybody okay? You're scaring me when you don't say anything. Okay. Okay. Now what? Okay. This is one of the bad things about having this, what is it, an 8-week class? So I'm going to have to go pretty fast and change gears an awful lot. I'll try to keep it somewhat manageable. Okay, a triangle if you ever take trigonometry, trigonometry is the study of triangles. That's all it means. And it's really I hate to sound nerdy here, but it's really an interesting class when you take what am I saying? Trigonometry. Very interesting. Triangles has interior, I-N-T-E-R-I-O, interior angles that add up to 180 degrees. Okay, so in other words, if you have pretend this is a triangle. Yes, I know my penmanship's bad and my drawing's even worse. This angle plus this angle plus this angle, interior, just like the interior of your car, the inside angles all add up to 180 degrees. So if this one is 50 degrees, this one is 60 degrees, that's 110. What would that one be? That one would be 70 degrees, right? 50 and 60 is 110. Okay, the interior angles, the inside angles, all will add up to 180 degrees, right? 50. Please don't tell Dr. Burke on me about using calculators. 50 plus 60 plus 70 is 180 degrees. Say, oh, Johnny, what a smart boy you are. No. Okay, again, add up to 180. So if we have this if you're so smart. Here you have, again, pretend this is a triangle. This angle is X degrees. This angle is X degrees. Okay, this is, if these two angles are the same, this is called an isosceles, or two angles equal, are the same. And this angle up here is X plus 60 degrees. Find the measure of each angle. So we take X plus 60 plus X plus X, okay? This plus this plus this will all add up to, the interior angles of a triangle add up to 180. Okay, so what can we do here? We can combine like terms. X and X are 3X. this is 60 here. I'm sorry. Sorry. I wish I could say I'm not going to make any more mistakes, but I am. Equals 180. Right? Right. So now we subtract 60 from each side. Very simple algebra. We have 3x equals 120. Divide everything by 3. X is 40 degrees. Now, is that our answer? No. We want to know what the measure of each angle is. So this one's going to, that one's going to be 40 degrees. This one will be 40 degrees. And this one will be X, which is 40 plus 60. Okay, wherever there's an X, we're going to plug in 40. This is 100 degrees. Okay, 40 and 40 is 80. 80 plus 100 is 180. So we are correct. Now, what could be more fun? It's good stuff, huh? Everybody okay with this? It's really very, very simple, but you look at it and think, holy crap, look at all that I just did. Or you just did. Okay, I'm going to irritate you with this, and this will be on, this is going to be on the final exam also. This next one will be on the final, and it'll be on test number 1, which will be, I don't know, next week, maybe the week after, something like that. If you have the area, area, first of all, is equal to length times width. Everybody remember this from 7th grade? So if you're given the area of a rectangle, this is the area of a rectangle, ECT. The area of a rectangle, length times width. So the area of a rectangle, ECT. The area of a rectangle is 100 square feet. We say this, we write it feet squared, but we say it's square feet. Okay? The area of a rectangle is 100 square feet. The length is 5 feet. What is the width? Now, this is real simple, but I tell you, we a lot of times we'll get fouled up with these godless word problems. So look, area equals length times width, right? Just plug in the numbers you know, solve for what you don't know. Do we know what area is? Yes, the area is 100. Do we know what the length is? Yes. Do we know what the width is? No. Okay, everybody with me here? Okay. So we divide everything by 5. So our width is 20 feet. Now on these problems, I like to draw pictures because I'm stupid. Area is 100. The length is 5. The width is, we don't know. Okay, so again, area equals length times width. Now, double check, 20 times 5 is 100, so we're correct, probably. Mm-hmm. Now, perimeter, P-E-R-E. Did I spell that right? I think this is an I here. Perimeter is the length of all the sides. Very, very simple. All we have to do here. So what is the perimeter of this one? Again, I'm going to draw a picture. This is 20. This is 5. Now, what do we know about rectangle? Excuse me. What do we know about rectangles? Opposite sides are equal and parallel, but that doesn't mean anything here. Okay, so this side over here is 20, and this side is 5. Okay, perimeter is like a fence. How far is it all the way around? If you go to Home Depot and you say, I want to build a fence, and what are they going to ask you? They're going to say, no hablo inglés. No, they're going to say, what are the length of all the sides? What is the perimeter? 20 plus 5 plus 20 plus 5 equals, we don't know. 25 and 25, this is 25 plus 25 is 50 feet. Okay, perimeter is very, very simple. Just add up all the sides. Okay. Take another drink of your Diet Coke. That's a good Diet Coke. It's a Coke Zero. That's good stuff. Mm-hmm. Okay. Okay. All right. Area of a rectangle is 250 square meters. The width is 25 meters. What is the length? And what is the perimeter? P-E-R-I-M-E-T-E-R. What's the perimeter? Okay. So our area is 250 square meters. The width is 25 meters. The length is, we don't know. So again, area is length times width. Now plug in the numbers you know and solve for what you don't know. Our area is 250. The length is, we don't know. The width is 25 meters. Okay. L times 25 or 25 times L doesn't make any difference. We're going to handle it the same way. So we're going to divide everything by 25. So our length is, that cancels out. Length is, what is it, 10 meters. Now, we want to know what is the perimeter. This is 10. That means this one's 10. This one's 25. I got it backwards again. 25. This one should have been 25. Right, so we to get the perimeter, excuse me, to get the perimeter, we add up all the sides. 25 plus 25 plus 10 plus 10. Now you can do it like this if you want. 2 times 25, right? Plus 2 times 10. And your calculator will do order of operation for you and spit out, was it 50, 70? Come on, stupid, think. This is 50 plus 20 is 70 meters. Right? Right. Again, I'm going to irritate you with this from time to time. Mhm. Okay. Okay. Does anybody want to do another one of these? Everybody okay with this? Tell me now, or I'm going to go on. Ratios and proportions. This is something that you'll use in real life. Ratios and proportions. If 5 pounds of apples cost $4, how much for 9 pounds? Okay, so what we want to do is we want to set up a ratio or a proportion. 5 pounds is to, this is to, is what the fraction bar means. 5 pounds is to 9 as, okay, 5 pounds here, $4 here. And here we don't know. Now you can set these up. You can set these up almost any way you want. You could do they just have to be consistent. You could also say 5 pounds is to $4 as 9 pounds is to X, right? Pounds to dollars, pounds to dollars. It doesn't make any difference how you set it up, but you just have to do it the same way on both sides of the equation. So the way we do this is we cross multiply. That times that times that. 5 times X is 5X equals 9 times $4, I think it's $36. Okay, now again, we have a very simple algebra problem. Divide by 5. X equals 720, I think. 36 divided by 5 is 720, yeah. Now look, when you're doing this, you have to ask yourself, does it make sense? Is it reasonable? 9 pounds costs $7.20 when 5 pounds costs $4. So this is maybe not twice as much, but it, you know, the poundage here is almost double. So what's double 4 is 8. So 720 is almost 8. It's pretty close. Okay, and again, if we set it up, 5 pounds is to $4, is 9 pounds is to X. Cross multiply again, and we get the same thing. 5x equals 36 divided by 5x is 720. So again, it doesn't make any difference how you set it up. Pounds is to pounds, as dollars is to dollars. Just make sure you set it up the same way on both sides of the equation. Okay, if 8 doctors charge CHARGE a total of $500 per office visit, how much would 12 doctors charge? CH. Okay, what do we have here? We have a nice pretty proportion or ratio. So we can say that 8 charges 500 as 12 charges X. Okay, 8 doctors charge $500. 12 doctors, we don't know. Doctors to money, doctors to money. You could also do it 8 is to 12, doctors to doctors, as 500 is to X. We can do it that way also. So again, we cross multiply. 8x equals, what is it, 6,000? Yeah. 12 times 500. Again, always make sure you entered it right. Yeah, 6,000. Not. Divide everything by 8. X equals 750. Now again, does it make sense? Is it reasonable? You got half again as many. You got 50% more doctors here. So what's half again? 500, 750. So we're correct, probably. And again, you can do it this way also, and you get 8x equals 6,000 divided by 8. X is 750. Okay. Here we did doctors to money, doctors to money. Here we did doctors to doctors. And don't forget, the 500 is going to go where the 8 is, not where the 12 is. So it's 500 is to X. Okay. 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 And again, I'm going to shift gears here. Now, if you'll recall from 7th grade, ANCE, distance equals rate times time. Take a drink of your Diet Coke. Now, the only thing that's kind of confusing here, I think anyway, is what is rate? Rate is speed. Okay, that's the only thing that's remotely confusing. So if you're given Cypress to Austin, is 175 miles, more or less. How long will it take you? How long will it take to go from Cypress to Austin? If you drive at an average speed, AVERA, of 75 miles per hour. How long will it take? Again, I don't know about you, word problems just make my brain collapse, even worse than it normally is. Okay, how long? Okay, remember in third grade they said underline the important stuff? And remember you said, I'm not doing that. That's stupid. Well, third grade teacher, she was right. How long is time, right? If you drive at an average speed of 75 miles an hour, how long will it take if we have distance equals rate times time? Now, all you do is you take the formulas and you plug in the numbers you know, solve for what you don't know. Distance. Do we know what distance is? Yes. Distance is 175 miles. Do we know what our rate is? Yes. Rate is speed. And how long is our time? Now we have 75 times t equals that. So we divide by 75. T equals 175 divided by 75. Is that correct? 175 divided by 70, yeah, is 2.33 hours. Everybody remember what the little bar over top of the 3 means? It's a repetend. In other words, it goes on forever. Okay, and if you're not sure, if you want to double check and make sure, you multiply 2.3 times 2.3 times speed, and that'll give you 100. Wait a minute, where's speed? There. So 2.3 times 75 should give you 175 miles. Right? Right. Everybody okay with that? Really very, very simple. Okay. All right. Okay, distance equals rate times time. If you drive at an average of 53 miles per hour, not miles per gallon, how far can you travel in 4 hours. Again, distance equals rate times time. Do we know what our distance is? How far is distance? So we don't know. Equals, what's our rate? 53. What's our time? 4 hours. So our distance is it 212? 53 times 4, 53. Yeah. And if you want to double check to make sure, you put 212 in here for distance and you do these two. Okay. And what about this? To get to Granny's house, 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 in time for Christmas dinner. How fast must you travel? In other words, what's your average speed? If Granny's house is 74 miles away, and you have 1.5 hours before you need to get there. Okay, so again, distance equals rate times time. Rate times time. What's our distance? Do we know? Yeah, 74 miles. What's our rate? How fast must you travel? We don't know. And what's our time? 1.5 hours. Again, very simple algebra. Divide everything by 1.5, and we get rate equals 74 divided by 1.5. Did I enter it right? Yes. 49, our rate is 49.3 repetend miles per hour, mph. Okay, distance equals rate times time. It's something you might also use in real life. Okay. Okay, let me review real quick like a bunny. My mother used to say that. Horrible woman. Mm-hmm. Mm-hmm. I'm going to review real quick. Okay, these are complementary. complementary angles. So if this one is 40 degrees, that one is X. We know that X plus 40, this angle plus this angle, will add up to 90. Subtract 40, subtract 40. X is 50 degrees. Now, double check to make sure. Sure you're right. 50 plus 40 is 90, so we're correct. Same thing with straight angles or a straight line. They're equal to straight line, supplementary, and they equal 180 degrees. Not super whiz bang important, but again, you're going to see these from time to time. Not only in this class, but in other classes. The vertical angles, vertic, not vertical angles. Okay, and vertical angles are equal. Okay, these two are equal, and these two are equal. And if you add them all up, it'll come up to 360 degrees, because if you'll notice, that makes a circle, 360 degrees. Okay, vertical angles are equal. You are going to see this, again, not a whole lot, but you will see it from time to time. A triangle, the interior angles, this, plus this, plus this. Interior angles of a triangle will add up to 180 degrees. Okay. And to get beyond that, it's just simple algebra. Okay. CTA. The area of a rectangle is length times width. Again, when you get a problem like this, just plug in the numbers that you know, solve for what you don't know. Now, perimeter, perimet, add all the sides. Now, in a rectangle, opposite sides are equal. Okay, so if you have this, this will equal this, that will equal that. Opposite sides are equal. Okay. Okay. What could be more fun? Okay, you have a nice, pretty quiz. Should be open now. Let's do, I don't remember. I think the 11th, something like that. Are there any questions? Anybody have any questions? Okay, it's time for my mid-morning nap. Okay, y'all have a good weekend, and I'll see you on Tuesday at 7 p.m. Back to normal time. Okay, and don't bring me any candy because I'm diabetes. I'm all eat up with the diabetes. But you don't care. You probably want me to die. I don't blame you. Okay, have a good weekend. Bye-bye. Bye, Bonds.